Good morning, students. Jai Swaminarayan. In last lecture, we are learn basic introduction, application, characteristics, uh, enabling technologies, few challenges, IoT various levels. Now we are discussed about IoT stacks. Basically, अभी तक हमने जो पढ़ा इसमें हमने मेनली देखा कि इंडस्ट्रियल रिक्वायरमेंट्स पे आईओटी बेटर रिजल्ट्स हमें दे रहा है और स्मार्ट मेंटेनेंस का कॉन्सेप्ट हमने देखा. बट रिसेंटली इन द वर्ल्ड ऑफ टुडे देयर हैज़ बीन अ सब्सटेंशियल बज़ अबाउट द इंटरनेट ऑफ थिंग्स एंड यू शुड पे अटेंशन टू, in which experts and researchers agree that IoT will bring significant change to both your personal and professional lives in the year to come. हमारे जो डेली लाइफ है इसमें बहुत सारे चेंजेस IoT से पर्सनली एंड प्रोफेशनली अभी न्यू एरा में आप देख पाओगे. ठीक है, इन विच the technological stack that powers the Internet of Things, or Things stack as well as like to call it, enable your company to create a new products and services which help you differentiate your offering from IoT. फर्स्ट हम डिस्कस करेंगे कि व्हाट इज़ अ टेक्नोलॉजी स्टैक in which we are basically use the platform, the Oracle, MySQL, Grails, Java, JUnit, Hadoop, Apache Ant Server, Spring Source, etc. Traditionally, the adoption of innovative technologies, which is accelerate after framework, language, protocol, and standards are defined. Each layer in a technology layer हमने ऑलरेडी डिस्कस किए हैं, जहाँ पे हम फोर्थ लेयर पे वाईफाई, GPRS, GSM, ब्लूटूथ वो डिस्कस किया था लास्ट लेक्चर में. ठीक है, ईच लेयर इन अ टेक्नोलॉजी स्टैक नीड्स टू इंटीग्रेट एंड कम्युनिकेट विथ द अदर लेयर ऑफ द स्टैक. सारे लेयर्स हैं वो पर्टिकुलर स्टैक्स वो इंटीग्रेटेड है और वो वन स्टैक communicate with another one. That means the layer structure are internally bounded. Okay, as a tech stack measures, it becomes easier and less expensive for your developers if you have them to create a new product and services. वो सारे layers है आप न्यू प्रोडक्ट डेवलपमेंट के लिए यूज़ कर सकते हैं, which is a less expensive. The IoT stack is rapidly developing and maturing into the Think stacks. This Think stack considered in three technology layers. The first is a sensor, second microcontrollers, and internet connectivity and service platform. Basically three layers, layer 1, 2 and 3. First one is sensor, second microcontroller, third is the aggregation and analysis of data, in which I give some enterprise IoT application designer review. Your use cases, the device requirement and existing data to better understand how to create a value. By better understanding each layer of the Think stack, you make better decision about the technology you should use for your IoT product. Layer 1 is a sensor. We are basically seeing in our vehicle there are many sensors are working over there. First is a differential non-contacting angle sensor. Second, combo sensor, steering torque for steering torque. Third, throttle position sensor, which is measure the engine conditions. HVAC sensor, steering sensor, fuel level sensor, wheel speed sensor, जहाँ से आप स्पीड मेजरमेंट आपने स्मार्ट मीटर देखा है सारे व्हीकल्स में. देन मिरर सेंसर, मिरर भी ऑटोमेटिक है. एक्सेलरेटर पैडल एंगल सेंसर, आप जो एक्सेलरेटर दे रहे हैं वो पैडल पे भी सेंसर लगा हुआ है. ट्रांसमिशन सेंसर, हेडलाइट रेंज सेंसर, चेसिस लेवल सेंसर, मोटर पोजीशन सेंसर. इतने सेंसर्स हम बेसिकली व्हीकल में नाउ डेज देख रहे हैं. ठीक है. सेंसर हैव बीन यूज्ड फॉर द ईयर इन अ नंबर ऑफ डिफरेंट इंडस्ट्री कंस्ट्रक्ट लाइक हेल्थ केयर, एविएशन, ऑलरेडी हमने लास्ट सेशन में पढ़ा है, ऑटोमेशन एज वेल. नाउ सेंसर आर so teeny and inexpensive. They can be embedded in all the device you use personally and professionally. The sensor layer of the IoT tech stack continues to expand as internet connected sensors are added to new products and services. Besides incorporating sensors into your smartphones and tablets, your innovative competitors are introducing new devices that contain numerous sensors. In layer 2, microcontroller and internet connectivity. This is the second layer in the IoT technology stack. Is allow for local storage, data processing and internet connectivity. A microcontroller is a small computer. You already know it's embedded within a chip and it helps your IoT device store and pre-process collected data before it's synchronized to your cloud database. Your microcontroller processes a processor, a small amount of RAM to hold the data, some kilobytes of EEPROM or flash memory to hold embedded software, and solid state memory to catch a data. Then layer 3 for service platform. The first two layers for the things stack embed sensor and microcomputers in your IoT device, but your IoT products profit from the service platform layer. This layer delivers a value to your customer by automating process and delivering rich data analytics. It is important for your service platform to create a feedback loop between IoT device and a device management software. The convergence between our digital and physical worlds stresses your IT operation by increasing demand for data management, storage, tagging and analysis. It's in your company's best interest to build your IoT service platform on robust cloud infrastructure so you can scale infinitely as your business grows with your new IoT product. Now question is how to extract the value from the things stack. The things stack isn't just for emerging companies or technology companies. The things stack will revolutionize your industry and create efficiency and a new product your customer love. With end-to-end IoT solution, you can now redefine your relationship, customer, and create a new data-driven goal-oriented outcomes. This is IoT stacks in which we define a three-layer. One is a service platform, second is a microcontroller, and first is a sensor, in which we are learn an example of a vehicle in which we are seeing the steering, position sensors, accelerator sensors, mirror sensors, transmission, headlight, chassis, all the parts are covered by sensors. Then next we are continue with IoT, CPS, SmartX, and a overview, in which the competencies of computing, communication, deep sensing, actuation, and analysis, which is enable a smarter version of commonplace and idea whose time has come. The different viewpoints, different names. Then, what is a real new about this? Is anything? This is a question. How does it change things for designers, developers, and practitioners? All the questions have a single answer. This is based on a stack value, characteristics, and basic architectures of Internet of Things have all the kind of solutions of this question. IoT basic definition you already know. The Internet has always connected things like computers and people over Internet. The enable communication for people is perceived as a communication like a mail and chat. To enable cooperating computer to present a single point information, which is perceived as a distributed like a web and a cloud. IoT things are not typical computing device, is a non-typical communicate, but to attach the internet you need a computer. To make a thing smart is a must attach with a network and a computer, which is attached with information flow. The degree of information couple, there are two types. One is a type that means a micro. Micro is a second level of IoT, which is studies before 5 minutes. The layer stack technologies of IoT. Second one is a loose, which is computer observes device. Why both are about the what can thing tell you and what can thing be told to you, in which the things it is a specific, its state is read by the sensor, in which on a specific category its a position, location, and orientation, and its identity by RFID. Then what can a thing be told to do? The thing specific is a change state, and unspecific, that means a switch, is a working like on and off. IoT as a confluence, we are seeing all the examples in lecture number 1, 2, and 3 as well. This is the fourth lecture. Now we are discussing the cyber physical system. Cyber physical system, that means CPS, is a computer system in which mechanism is controlled by algorithm. It is a physical software component are deeply integrated. It is used to operate at different scales, exhibit a multiple and behavior modalities, and interact with each other in way that change with context. The example of cyber physical system include a smart grid, autonomous automobile system, medical monitoring, industrial control system, robotic system, and automatic pilot. In cyber physical system is integrated sensing, computation control, and networking into physical objects and infrastructure, connecting them to the internet and to reach others. The next generation of engineer systems that require a tight integration of computing, communication, and control technology to achieve a stability, performance, reliability, robustness, and efficiency in dealing with physical system of many application domains. So, same as IoT, then weight and control. A cyber physical system can be found in area as diverse as aerospace, automotive, chemical process, civil infrastructure, energy, healthcare and manufacturing, transportation, entertainment and consumer appliances. Now we are taking few more examples like a mobile cyber physical system. This system is a physical understudy as inherent mobility are a prominent subcategory of cyber physical system. The example of mobile physical system include a mobile robotics, electronics transported by human and animal. The rise in popularity of smartphones has increased interest in the area of mobile cyber physical system. Smartphone platform make ideal mobile cyber physical system for a number of reasons, including significant computational resource such as processing capacity and local storage, multi-sensor IO device, touchscreen, camera, GPS, speaker, microphone, light sensor and proximity sensor. Proximity sensor is able to detect the presence of nearby objects without any physical contact. Remember, the proximity sensor is a sensor able to detect the presence of nearby object without any physical system. This is for example only. And multiple communication mechanism such as a Wi-Fi, 4G, H. H means enhanced data rate for GSM evolution, Bluetooth for interconnecting device to either the internet or other device. Then in mobile cyber physical system, high level programming language which is also used to enable rapid development of mobile CPS, node software such as Java, C# and JavaScript. Then readily available application distribution mechanism such as Google Play Store and Apple Play Store. Then end user maintenance and upkeep including frequency recharging of the battery. This is just not in GTU syllabus, but for example I discussed the mobile cyber physical system. Okay, then next, control system. A plant evolve according to application, physical laws, phenomena and some input. The governor control the ensures and target characteristic of the plant state and output by observing output and modifying input. A digital or hybrid control system is a wholly or a partly a computer algorithm. A network control system is controlling the computer is a remote, like we are already discussed the microcontroller and chip at level 2 of IoT. Now back to CPS, a controller that closes the loop in the physical world by using computational in cyberspace. A plant may be distributed, controller may be distributed and perforce must be real time for some definition of real time entities. Now we are seeing the sensor actuator architecture in which we are plan some activities, we are visualize some things. Now control of vehicles, we are already learned the how many sensors are used in your vehicle. Then your device, your computer, your CCTV surveillance, that means a smart surveillance. Then maintenance machine, this is already discussed in the application of IoT. Now we are learned the CCTV which is connected with your system, which is follow some architectures and algorithms as we discussed in the microcontroller and IoT stack. Now a signal received by wire connections and the data is collected by cloud. This is the circuit, the microcontroller or chip which is used in entire operations, which is also connected with the cloud for a data storage. The device and CCTV both are connected with the cloud. We use some kind of sensor for collecting the information at a real time. Now second type, we are use the high speed internet. For same, we are use the Wi-Fi connections. This is additional devices, the batteries. Now this is a high speed fiber connection. This is a battery operated CCTV for video surveillance for security. Now all devices are connected with the cloud and get informations of weather, agriculture or factory or the smart homes or the traffic or any kind of data collected from a cloud. This is a layer structure of IoT in which we are discussed all the hardware connected with your system. Same as a layer structure, and we follow some algorithm which is used in robotics and artificial intelligence, as well as data mining, data analytics. The entire systems will use infrastructures of a cloud in various layers. Now connected nodes also access there with access control and management. System task, which is a sensor platform program. Sensor which is used to read the data and sending the data, which is used the pooling network, battery management, meta task, capability reporting, configure on command, self configure on a read or real time. Now as another end is the pole sensor, which is process data, achieve, visualize and fuse, manage the sensor and configure a task. This is the steps behind the entire operation. Now collective task, the meta task, which is basically routine, schedule a sleep, localization support in network fusion, in network self configuration. System component you are already seeing here in architecture. This is a smart card, microcontroller and the chip which is used as a system component. This is adapter. Now your device which is used for communicating, does act as a one kind of node. This is the second layer. Now by card, all the data were collected and processed and send it to the client. We are using Wi-Fi connectivity, smart cards, cell which is used in board. This is just a scenario how to work a sensor at a second level and interconnected with an entire system. Now we see the designer and developer POV. The agile early complete a prototype helps to inefficient to optimize analytics without knowing a sensor characteristics. आपको सेंसर्स की कैरेक्टरिस्टिक्स, इसके बेसिक टेक्निकल पैरामीटर्स और फंक्शनैलिटीज़ वो आपको जानना जरूरी है, ठीक है। और डिसाइडेड डिस्ट्रीब्यूशन ऑफ algorithm without understanding networking overhead trade-off. In the end, optimizing phase, the area expert should design and develop a separate component, but not in the beginning, at a last. Ultimately, a long known truth, a comment on premature optimizations, a Brooks principle, or throwing the first one way. But now, designer of cyber part has to understand something of the issue of interfacing with physical. Now, we are learned Internet of Things versus wireless sensor network. In 2020, there is often confusion in articles regarding the difference between IoT and WSN. WSN, that means wireless sensor network, is often caused them to be blurred together. In this article, we'll go to the sum of major difference between these two concepts and explain how they are in fact quite different. Basically, it is based on internet connectivity, and WSN is a work as a subset of IoT. For example, Internet of Things and wireless sensor, which is used to collection of wireless sensor that may or may not be connected to the internet. IoT exists at a higher level than WSN. In another word, WSN is often a technology used within an IoT system. A large collection of sensors, as in a mesh network, can be used to individually gather data and send data to a router to the internet in an IoT system. It's also important to note that the term wireless sensor network is not nearly as in composition as the Internet of Things. Consists of a network of only wireless sensor. If the network was to include a wire sensor, it could no longer be labeled a wireless sensor network. This is unlike IoT. Essentially, any device that connect to the internet can be considered as an IoT device. An IoT system can thereof be interpreted as a group of many IoT devices. Now, basic components are for communication. We use a socket programming, routing, Wi-Fi network. We are already discussed sensing. We are use triple BK headless programming, device trees and reading pins. You need to be aware of voltage, possible some circuit, that means a board, analytics, the smart of the system, history, predictive, model based and semantics, then orchestration, efficient sensing, analysis program design, transition to distributed, and need to be aware of timing issues, that means concurrence. The summary of entire session is the IoT type application system on an exciting new opportunity which is used all over the world, global, likely to grow even more in the near future. It's effective, must understand all components of the architecture to some extent. We are learned the level 1, 2 and 3 various layer and architectures of entire IoT systems with hardware. No better way to than by doing. Hence, in this course, I hope you enjoy the entire session. And now we declare the unit number 1 is completed, and next exercise, question and case studies is uploading on Google Classroom in short time. Thank you. Jai Swaminarayan.